Welcome to the Octopod. I'm Kyle Davis, head of the Office of the CTO. Join us as we dive into the latest technologies and trends shaping business. Whether you're a tech enthusiast, a business leader, or just looking to stay ahead in the digital age, this podcast is for you. Let's unlock opportunities with technology together. Let's jump in. Everyone, this time we're going to delve into the topic of AI, and I'm really excited to be joined by Emily from Lenovo. Emily, would you introduce yourself to everyone?
Yeah, thanks, Rob. So thank you very much for having me. I really appreciate it. I'm Emily Barrett, and I work for Lenovo's Infrastructure Solutions Group. So that's everything Lenovo does, apart from the bits of Lenovo that you will know very well, which is our laptops, tablets, and also mobile phones as well. So I do everything other than that. And my role specifically is as a solutions architect in that part of our business. And I have a specialty and responsibility for our AI business in the UK.
Excellent. I think this is possibly the cool part of the conversation, really, which is, where have we actually deployed this stuff and what real differences has it made to organisations, cities, countries, people, etc. from that side of it. And maybe we can explore a little bit of the challenges, the lessons learned, some of the stuff that was deployed, etc., just to give some examples, really. And I think let's start with probably the more obvious use case in the industry, which is computer vision into the retail sector. I mean, because actually for people listening, it's quite easy to conceptualize.
Oh yeah, because we can get into a shop.
We can point a camera at something and see what's going on. But actually, so you can't really show it on a podcast. But I was watching a great video of what the actual AI sees on a shopping cart and actually watching it as it identifies the products. And it's if no one's seen it, I'm sure you can probably Google it. But actually, it's quite informative to see what the computer sees and actually how it then actually tags and identifies the products and what's going on.
And it is really interesting to see how these things work. What do they actually look like in practice? And is this all pie in the sky? Or is it actually something that you can roll out and achieve in your business? And so going back to that computer vision in retail example, we mentioned in, I think, the first episode about things being misscanned. And so this is a problem that occurs on self-checkouts, but also occurs a little bit on manned checkout lines as well. And we've been working with a US-based retailer, someone called Kroger that you might have heard of, and they've got thousands of stores. And we started this off as a proof of concept in a couple of stores with them and looking at their self-checkout because people were mis-scanning. So just to set the scene a bit, when you go to a self-checkout, and you'll have noticed in a supermarket that traditionally you scan something through and you put it on scales and it's the weight that it's taking to work out whether you have scanned an item and put it in the bagging area, which is why it freaks out if you put something in the bagging area. But if you base something just on weight, if somebody has swapped a sticker for 500 grams of broccoli for 500 grams of steak and has scanned the steak with a broccoli sticker on it, a scale can't tell you what it's 500 grams of. It can only tell you that it's 500 grams. Now, obviously, 500 grams of broccoli has a different price point to 500 grams of steak. So we worked with Kroger to look at using computer vision to actually identify the objects that are being scanned, right? So rather than just going, oh, this weighs this, can we make sure that this actually is what's being scanned? So this was the first use case we looked at with them. And they saw a significant reduction in their losses that they're seeing in terms of going through the store. For that use case.
And it's a massive problem in retail.
Yeah.
Generally, our retail team talk about it all the time. That loss challenge within retail. Yeah. So being able to solve that is really key. But one of the challenges I get is, and you mentioned that Kroger have thousands of stores, is actually how do you make this commercially attainable across that scale? Because it's great when you look at it in one store and if it's going to cost thousands and thousands and thousands, actually scaling that can be a challenge. So there's got to be an infrastructure optimization piece in there somewhere.
Yeah, that absolutely is. And part of this comes down to solution design. So this is why I think POCing it in a couple of different size stores is really helpful here. Because if you're looking at a massive store with a larger number of checkouts than a smaller store might have, you're going to need more processing power for that large store than you are for a small store. So you need to make sure that the processing power that you are putting into each store environment is scoped appropriately. And the reason why I'm talking about putting processing power into store environments rather than sending this off to a cloud, whether that's a private, public, whatever type of cloud should be processed, comes down to that latency of that decision. Because in this instance, you need to know pretty darn quick, i.e. before they get out the door or before they get through the self-checkouts, whether that item is what it's supposed to be, right?
It's got to be near real-time realistic answer, yeah. So.
Exactly. So you haven't got time to be sending this data backwards and forwards. So you need to be doing this processing locally. And this is one of the big things with computer vision in particular. You need to be doing the processing where the data is. So looking at doing different size devices for different stores with different processing capabilities is key here, right? And this is one of the things that I think is a bit of a learning as we come out of this, is different camera numbers need different device sizes, and we need to make sure that we are scoping appropriately to maximize that ROI for customers, because why would you want to spend more than you have to? Now, I say that with a caveat, because we're actually looking at expanding the use cases that we're using things for here, and we're trying at the moment running monitoring the manned checkout lines as well, because on manned checkout lines you have a problem if someone's mum comes in to buy their groceries and certain items might not go through the scanner. They might get passed behind somebody. So there are multiple ways you can use computer vision here, and making sure that you've scoped your infrastructure appropriately on site to be able to actually do it scalably is important, because you start out with one of these things and you want to be able to roll out to more. And so from our perspective, it is really making sure that infrastructure is scalable and appropriately sized. So you don't want to be too big to start with, because that wipes out your ROI. But equally, you've got to be able to scale it too.
Oh, that makes sense. So moving on, we were talking a little bit about a more human-focused use case, which I think is really cool to touch on, but this was for the Scott Morgan Foundation.
So Lenovo have been working with the Scott Morgan Foundation for a little while now. And one of the more recent projects we've done with them, which we debuted at the Consumer Electronics Show, is creating avatars for people with disabilities. And this is because at the moment, if you look at the life we expect people with severe disabilities to lead, we are not expecting people to thrive. We're expecting people to just be able to exist. And that, like, on a human level is really poor. Like, as a society, we need to do better. We cannot be doing this. We need to be finding ways to make sure that people can, for example, communicate efficiently. So we were doing a piece of work with the Scott Morgan Foundation around this, on creating avatars for people with advanced stage ALS, which is a really, really horrid disease, and basically paralyzes you. So people familiar with Stephen Hawkins,
he's trying to take that, because obviously everyone is familiar with Stephen.
Yeah.
But you also attach a very non-human output to that. Mm-hmm. So this is, I guess, where AI is allowing us to create a much more human interface.
Yeah, absolutely. So this is where we're able to use generative AI to create a much more human interface. So we worked with them to create an avatar for a lady called Erin, and the avatar we created is a full body scan of her, and it uses her voice. So it enables her to actually communicate with people in a very human way. So multiple different layers to this. So it's not just the avatar, it's also looking at how you do that text-to-speech prediction of what that sentence is going to be. So how do you actually make it easier for people to use rather than a traditional text-to-speech or predictive text tool? Because actually the reality is they don't work particularly well for people with disabilities, or particularly with this specific disability.
And I guess from a technology perspective, though, we're trying to run this in a lightweight, long-term serviceable environment as well, because it's not like we've got a data center that we can attach on the wheelchair, is it? So we've got to think about that, which I think really highlights actually how much processing power we can now place into such a small environment.
No, we absolutely can now. If you start looking at things like edge servers now, you can pack a lot of punch into a very tiny device, which enables this kind of technology to be actually practically used. And if you look at edge devices, it's also looking at how you deploy this kind of stuff outside of a data center, because a data center is a very clean, controlled environment. You've got set temperature ranges that it falls between. It's not dusty. It's not, it's not moving around all the time. Yeah, you're not exposing it to extreme temperatures or extreme humidities. And how do you, as a technology provider, that is a challenge to overcome, right? Acoustics as well. Something that people don't think about is how loud are these? Because if you're putting one of these near somebody, whether that's in a retail environment or whether it's on someone's wheelchair, can't be loud.
Can't be hummy.
Because it's going to drive people
crazy.
Yeah.
So this sparks a thought and a conversation then, just to tag on, is everyone really probably associates the likes of NVIDIA, Intel, AMD, etc. with the AI space. You need a GPU, you need an AI processor or whatever it happens to be. You're not going to load one of these, 10 megawatt servers with GPUs on the back of a wheelchair. So we train that model, and yes, we made a lot of GPU for that side of things, but you see a lot of use cases now where actually the inferencing, the using of it actually doesn't need that level of grunt, and actually maybe CPU is the answer in this space.
Yeah, and for sure, and it depends the level of analytics you're doing, as to there is a point at which a GPU becomes more efficient, but this is all about getting that balance, right, and sizing appropriately. So it links back to what we were just talking about in terms of making sure that what you're using is the right tool for the job, right? You don't want to be using a sledgehammer if you don't need a sledgehammer.
Yeah, that makes sense. But I guess the two themes through that is about scalable edge infrastructure that is of the right commercial point to be deployable at scale. It's got the right resilience and robustness to work within the environments that it has to do, which is things that generally isn't considered for IT infrastructure all the time. There's a lot of data requirements, as we talked about in here, but actually we talk about that collaboration piece, especially for the Scott Morgan piece. There's a lot of people that need to be involved in that project, but a lot of them aren't even anything to do with technology at all. They're the actual people that you need to scan and record voices for and all this sort of stuff. So it all feeds back to them.
Yeah, there's core things that we were talking about in the previous episode in terms of how you get these projects to succeed. That collaboration piece, cannot overstate that enough. That it is not just a technology thing. And I would really urge organizations to stop thinking of AI projects as a technology thing. Yes, technology is part of this, but you need people with that domain expertise. It won't work without them.
No, that makes perfect sense, and I think that's a great takeaway from the real world. It's like, yes, we have the experience together to deliver these things, and actually understand all the pitfalls, all the challenges, etc. But actually, there was some really defined outcomes in both of them use cases, which
is exactly what we were trying
to do, and there was a clear purpose, a vision, and value to come out of that. So we're nearly at time, but I'm going to give you a choice now, because we did have two options. So either we can talk about manufacturing or smart cities, but I'm only going to give you one.
Oh, let's talk about manufacturing then. Smart cities, I think we touched on a little bit in the last episode with the collaboration piece. So I guess we've also, in terms of manufacturing, multiple different use cases we look at. But breaking news, Lenovo is a manufacturer, in case you didn't know.
Right.
We manufacture IT equipment. Shockingly. So for us, talking about manufacturing and using AI within manufacturing comes really naturally, because it's something we're doing within our own factories. So we've been using computer vision now for quite a while on our production lines to do things like quality checks. And one of the reasons we do this is because and this may sound awful, humans aren't actually very good at spotting things or spotting patterns. We all think we are. The reality is, and I hate to break this to you if you didn't already know, we're not. Computers are though, right? And computers, when they look at something, they don't get tired. If you are stood doing quality control on a production line for a however many hour long shift, fatigue is going to kick in. Things are going to get missed.
If that device leaves the production line and ends up in a consumer's hands or in a data center or something, and there's something missing, that's cost.
Exactly.
But also reputation.
Yeah, it's cost, it's reputation. So it really, like, quality control really matters. So having something to point out to a human, just go and double check that screw because it doesn't look quite right. Rather than, we're not talking about replacing humans here, right? We're talking about augmentation. We're not at the point now with AI where it's going to replace humans right now. Come back in 5 years' time, might be different.
There's a whole separate conversation.
Yeah, I was going to say that's a whole different podcast.
Let's leave that one for now. But I think,
in terms of value for that supply line, being able to do that initial screening using a computer which never gets tired is really, really important, right?
I think it's great that we've got these sort of mix of traditional predictive AI that we talked about at the start, adding real business value, but also then the generative AI making such a difference on a human level. And I think that's what a great balance to end the conversation on, really, is actually the use of that entire technology portfolio to do some really core and actually, unfortunately, quite boring stuff on the manufacturing line versus some really life-changing stuff at a human level. So thank you for sharing them, and hopefully it just gives people a few insights into what's happening in the market. Thanks for listening. I've been Rob Sims, Chief Technologist for CDW.
And I've been Emily Barrett from Lenovo.
Thanks for tuning into today's episode. Be sure to check out the back catalogue for more great insights. Don't forget to subscribe via your favourite podcast platform so you never miss an episode. We appreciate your support, and if you have a topic you want us to cover, feel free to reach out. Catch you next time.